Lesson 6.4 Heat and Temperature Change. Heat is the energy that flows from a higher temperature object to a lower temperature object because of the difference in temperatures. So heat is energy, and it goes from high temperature to low temperature. Since it's an energy, the unit are joules, but we also tend to use calories or kilocalories. Kilocalories have a capital C, regular calories have a lowercase c. Kilo, of course, means 1,000, so a kilocalorie is 1,000 regular calories. Kilocalories are the calories we use. We're talking about the energy in food. If an object feels hot, the heat is flowing into you. If an object feels cold, then the heat is flowing out of you. Since heat is an energy, other types of energy can make the same effect as heat. So 1 kilocalorie is 4,186 joules. That's an important conversion because, again, the kilocalories are used a lot in food. If you're curious, 1 calorie, so 1 regular calorie will raise 1 gram of water 1 degree Celsius. And a kilocalorie is 1,000 of those, or the heat it takes to raise 1 kilogram of water 1 degree Celsius. To increase the temperature of an object, heat is required. The amount of heat required is related to, well, let's think, what do we have? The mass of the object, makes sense. The more stuff there is, the more there is to heat up, so the more heat will be required. The amount of temperature change, if you want to really make it a lot of difference in the temperature, you'll need a lot of heat. And the material of the object, because you know some objects heat up way faster than other objects. Like your metal pan heats up way faster than, say, water. We put that together, we end up with the formula Q. Q is the heat, so the heat equals M, mass. C is the specific heat capacity, so that's the material. So we have our mass, our material, and our change in temperature. So the heat equals MC delta T. Measuring the change in temperature of different heated objects, usually water with an unknown, inside a thermos can be used to measure the specific heat capacity of the object. So we have, it's actually 2 cups, so you have a cup and then another cup in an insulated cup, and you have water at a known temperature, and you plop in the unknown object. And then you can see how the temperature changes. And once the temperature gets down so it's not changing anymore, then you'll know how much heat the water absorbed and then how much heat the object lost, and from that you can identify the unknown material. A pot of 10 kilograms of 15 degrees Celsius water is put on a stove and brought to a boil. How much heat was needed? Well, let's see. Q equals MC delta T. Our mass is 10 kilograms. Specific heat capacity of water is 4,186. Oh, wait, that looked familiar. Yeah, it's the same as the conversion factor from kilocalories to joules. And our change in temperature, oh wait, what's the temperature when water boils? That's right, 100 degrees Celsius because it's boiling. And we started at 15 degrees Celsius. Run that through your calculator, and you get 3,558,100 joules. Wow, that's a lot of joules. So when we were dealing with just regular mechanical energy, if we got 1,000 joules, we were was pretty big. Now we're talking 3.5 million joules. So you'll probably write it as 3.56 times 10 to the 6 joules, or 3.56 megajoules. What is the increase in temperature of a 50-gram nail when it's hit by a hammer with a force of 500 newtons? Let's say the length of the nail is 0.06 meters and a specific heat capacity is 450 joules per kilogram degree Celsius. Well, we'll start with our heat is mc delta T. So we're changing our temperature. The mass is 50 grams, so that'd be 0.050 kilograms. Our C is 450 joules per kilogram degrees Celsius. And we're looking for the change in temperature. What's our heat? Well, heat's energy, right? So our heat is energy. Energy is the same thing as work. Work is force times distance. We have a force of 500 newtons and a distance of 0.06 meters. So that means our work is 30 joules. So that means our Q is 30 joules. So if we divide, that means our temperature changes by 1.33 degrees Celsius. And if you keep banging and banging and banging onto a nail, trying to get it pound in, or some other piece of metal, if you keep hammering really hard, you keep putting the kinetic energy and putting it into the nail, which isn't going anywhere, and it turns it into heat. And since you keep putting energy into it, the temperature keeps raising and raising and raising. I remember as a kid trying to bend a piece of metal to hold some cable together, and by the time I got it pounded out, I picked it up and burnt my fingers enough that they blistered because I put so much energy into the little piece of metal. That's all for today. Read section 14.3 for tomorrow. Have a good day.